Okay, grade 12s, let's finish recording the homework for exercise 7, page 111. We'll go through this a little bit quicker now, seeing as you should have a hang of what we are busy doing. So we'll look at question C. C says that h of x is the same thing as x to the power of 3 minus 2x to the power of 2 minus 15x. Right, so we'll get into the habit of getting the derivative first, which is 3x to the power of 2 minus 4x minus 15, and then getting the second derivative, which will be our habit for every single cubic function we draw. You'll see later when we've got cubic functions that have one stationary point or no stationary point, it's going to be a little bit different, but this idea you can take straight through. 2 times 3 is 6x minus 4. So we're just getting the derivative of each of these, and then we get started with our x-intercept. Well, I always say y-intercept first because it's the easiest to see. And we get our y-intercept by making, remember we are drawing the original function, so we go back to our original function, make x equal to 0, and once you do that, once you make x equal to 0, you'll get 0 as well. So the y-intercept will be 0 and 0. Next up with our x-intercept, what we do is we make h equal to 0. And then you'll see we get this. And this is similar to question A that we've already marked. We'll take out x as a common factor. We're left with x squared minus 2x minus 15. We factorize the following: x minus 5, x plus 3, and we get our 3 x-intercepts. So our 3 intercepts would be x equal to 0, x equal to 5, or x equal to negative 3. Remember, we've just been working with the original equation up to date, so everything that we've calculated stays the same. If you made the x value 0, the x value is 0, and the y value is 0, the answer that we get. In this case, the y value is 0, so all of these y counterparts will also be 0. So the coordinates for this intercept would be 0 and 0, and then this would be 5 and 0, and this will be negative 3 and 0. In this case, we've got the y-intercept and the x-intercept. Now we can get to the stationary points. So we look at our stationary point. I'll use the shorthand SP over here, and we get that by making our first derivative equal to 0. Three x minus 2 minus 4x minus 15. Factorize this. Is 3x and x. Our signs will be different. We're using factors of 5, 15 and 3. That will give us 4 if we subtract them. If you look at that combination, we're going to be using 3 and 5. And then we want to get a negative, so that would be the case there. So we get 3x squared minus 9x plus 5x minus 15, and all of that works. So then again, our x value here will be negative 5 over 3. Or our x value over here will be equal to 3. Right, we are drawing the original equation. So these values are going to be subbed into the original equation. We're not going to, if you sub it back into this derivative, you're just going to get 0 again because that's what you've just calculated. So if we do this, we take our x value here, we sub it in there, and we get something like the following. 400 over 27. And in the next case, we sub 3 back into our original equation. So we'll do this. And we get 27 minus 12, that's 15, minus 45, so that's negative 30, I believe. We'll double check that. 3 goes in here, 27. That's, oh, so that's 18. And that's, okay, so that should be 36. Let's see. 36 sounds good to me. Minus 36. Like so. Okay, cool. So we've got the stationary points, and let's get the point of inflection now. Point of inflection will make our second derivative equal to 0. Like so. Second derivative is 6x minus 4. I don't know why I'll be using f now all of a sudden. And we get that x is equal to 2/3. Again, we are using our original equation. So we go back to the original equation. That's what we're trying to draw. We sub in 2/3 and minus 286 over 27. Okay, so we've got our different points that we can plot now. We've got the y-intercept, the x-intercept, as well as our stationary points, and then our point of inflection. So let's get started. We'll do what we normally do. We look at the original function, which is x3, x to the power of 3 minus 2x to the power of 2 minus 15x. We've got our y-intercept, which is 0 and 0. X-intercepts, which will be 0 and 0, 5 and 0, negative 3 and 0. So that we arrange that in ascending order. And then the stationary points, we've got negative 5, 3, together with 427. And then this one, we've got 3, negative 36. Then of our point of inflection, this is not a point of intersection. In this case would be 2/3, 2 over 3, 2/3, and negative 286, 27. Now, normally I get a question from the students, should they be writing this, should they write it as decimal or fraction? I prefer fractions. I would prefer this as a mixed fraction. That would make it even easier for you to sketch the following. But in this case, we're going to use our calculator anyway, so we should be fine. Now, looking at these values, I don't see any of them going way too negative. So the smallest x value that I see here is minus 1 and 2/3. And then if we're looking at the y values, they don't go too out of control. We've got the 14, which is quite high. And then over here, we have got our 11, negative 11 point something, which is quite low. So we're going to need a little bit more space than we used to, but let's do our interpretation first to make sure that everything is solid. Look at our a value. Our a value in this case is equal to 1, which means it's a positive value there, which means our function will be smiling at the end like this, which means the first part of it will be frowny. So there's a smiley, there's a frowny. So we know this is the general shape. If our coordinates do not agree with this shape, we know we messed up somewhere. Okay, so let's try and draw this. We will probably not fit this in the screen, so we're going to be counting in 2s for the y-axis. For the x-axis, yeah, we'll be splitting them as well. So let's look at what we can do here. For the straight through here. And then there's 0. So let's say 2, 4, 6, 8, 10, 12, 14. Barely get that in there. And then at the bottom, we got a negative 10, I believe. So 2, 4, 6, 8, 10, negative 10 over there. We'll be working off those points. And yeah, now we can do the list. So our y-intercept is over there. We see that's our x-intercept as well. Then we've got 5 and 0 and negative 3, 2, 4, 6. Okay, so we'll try and fit this in, but we'll count in ones this time. 1, 2, 3, 4, 5. That's our one x-intercept. 1, 2, 3, negative 3 is over there. Then let's look at our stationary points. We've got minus 5 over 3. That's minus 1 and 2/3. So there's our minus 1. 2/3 will be 2/3 of the way that side. And then the 400 divided by 27 was 14 odd. That's 14.81. So there we go, minus 1 and 2/3. And we go all the way to 14.81. So that's going to be close to the middle of this one, seeing as we're counting in twos. Let's just make it there. And then if we look at the other one, the 3 and negative 36, woo, that's going to be all the way down here. So we are going to be borrowing, this is 10, 11, let's split that out. 10, 11, 12, 13, 14, 15, 16, 17, 18. We're going to be going on forever and ever and ever. But luckily we counted in two, so that shouldn't be an issue. That's 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Just get that there. Cool. So we've got that negative 36 somewhere over there, I believe. And then this was 3, and we'll plot those points. 1, 2, 3, all the way down here. Something like that. Again, not completely to scale, especially with how we're going to draw it now. Let's just give us some room. Now, we look at our stationary points. We've still got a point of inflection to plot. The point of inflection should be here next to the minus 10 somewhere, because we had minus 10.6 for that, this over here. So we've got 2/3. There is 1. So 2/3 should be somewhere over there. There's a negative 10. And this was negative 10.6. So it should be somewhere. We're counting in twos, so it should be actually closer to there. Something like that. That's our point of inflection. And we'll see if we get through all of this. Now, according to what we see over here, it should be turning like this first. And then it should be turning like this. And it seems like it makes sense. So let's draw our cubic function. Turns through there, intersects the x-axis right there, turns through there, goes up, and goes through there. We'll be plotting that. Please remember to plot your points. And yeah, that's going to be important. So we've got our 0 over there. We've got our 5 over there. And your lines will be better because this won't be a scale they'll use in your exams. And then this over here was our turning point, which is minus 5 over 3 and 427. And then we've got 3 and negative 36 over here. And then for this one, we've got 2/3 and minus 286. Okay, something like that. Again, the scale they'll be using in your exams will be much better. You won't have to stress about doing something like this, getting something very small like this, minus 36. But let's get on to the next question, question D, which says that we've got this one over here, which is a little bit different to what we've been seeing with the work now. We'll just get we've given the original equation over here, and we will look at the y prime. Okay, so we've got y prime, which is equal to negative 3 x to the power of 2 plus with 6x. This will fall away, right? And then we get y double prime, which is negative 6x plus with 6. Let's get going. Our y-intercept in this case is not going to be 0 and 0. Our y-intercept, if we make everything, all the x's equal to 0, we'll be left with negative 4. So it's going to be 0, negative 4. Our x-intercept in this case will make y equal to 0. And we'll solve the following. Now, this is one where we start with, when we try to get our x values, it's no longer the easy or the usual type of factorizing that we've been doing since grade 9. this will be actually using a bit of a guessing game. So what I tell my students to do is I tell them to use the table on their calculator. So go mode, go table, you type in this equation, and then you start at -5. You make your start value -5, and you make your end value +5, and then you make your step 1. So the step just counts, it's going to be counting from -5 to +5 straight through. And that's going to give you your x-intercepts in this case. Now, you can guess them. So you can try and guess what the x-intercepts would be to solve them. In this case, it seems like -1 will actually be quite a good one to work with. But for those of you that want to know how to factorize it properly, let's do that. With x to the power of 3, we'll divide straight through with the negative like this. And now what we're seeing when we're doing this is when you use your table, we're using x values. So we're guessing x equal to 1. Let's try x equal to 1. That's 1 minus 3 times 1. That's minus 2 plus 4. That's not working out because when you substitute x equal to 1, you're not getting 0 again, right? So what I tell them to do is then sub x equal to -1. So this will become -1 minus 3 times that will become +1 again. So that's -1 minus 3, that's -4. And -4 plus 4 does give me 0. So we see that x equal to -1 is a solution. So for our question, for our equation over here, we see x equal to -1 as a solution, which means one of the factors has to be x plus 1. Right, and now for the next one, we try some more values. So let's try x equal to, well, we tried 1 and -1. Let's go to 2. We try 2. So x 2 to the power of 3 is 8. Minus 3 times 4, that's going to be 8 minus 12. So that's -4 plus 1. We see x equal to 2 is also a solution. Okay, which means for this, our factor should look something like that. But remember, we're expecting to get 3 x values. So we're expecting, because it's x to the power of 3, so we're expecting to get 3 solutions for x. So there's 1, 2, and now we need a third one. So what we're just going to do then is to see what the third one is, because if you look at the previous questions that we've done, you've seen some of the x values repeat. So how would we know which one of these x values is repeating if there is one repeating? Like, how do we know whether it's -1 that's repeating or whether it's +2 that's repeating? So we just go look back at the original equation. Remember from grade 9, what we've learned is when you multiply the first terms in these brackets, we want to get the first term if it's written in its standard form. So x times x times x should give me x to the power of 3. And now if we multiply the last terms in all of these brackets, we should get the last term. So 1 multiplied with -2 is -2. -2 multiplied with -2 will give me 4. So we see that, okay, it was -2 that was repeating. And the table method won't show you if it's repeating or not. So you're going to have to understand how to do this. And then now looking at this, if we want to find this trinomial over here, you just multiply these two brackets out. It's going to be -4x plus 4. And then you factorize it perfectly without anyone knowing whether you did it with your calculator or what. So there we've got all of our x-intercepts. Let's look at our stationary points. We'll make the first derivative equal to 0. We'll divide straight through with the -3. You can take out -3x if you want. It's no stress as long as you don't. Divide with x like so. And then we see our stationary points at this stage. We'll get x is equal to 0 or x is equal to 2. Okay, we are looking for stationary points on the original function. So we take this and we sub it back into our original equation. And if you do that, you'll get that the turning points will be at 0 and -4. And there will be a 2, well, the other turning point will be 2 and 0, which is, we expected that over here, and we also expected that over here. So this is going to turn into a very interesting graph. Next up, we've got a point of inflection. we'll take the second derivative and make it equal to 0. X is equal to 1, and we'll sub that back into our original equation, and we'll get 1 and negative 2. Okay, now we can draw this. But before we can draw it, we need to understand how is the function going to look. The original equation looks like this. So according to what we've learned, the a value is negative 1. That means it should be a frowny at the end, so it should look something like that at the end, which means the beginning has to be a smiley because it has to be a smiley and a frowny. Okay, so let's draw this function. Let's just look at our values first. These are intercepts, so nothing too hectic there, nothing too hectic there. This looks like the first nice one that we'll be able to draw to scale. And we'll just fill in these values so it's easier to draw. And then our point of inflection, not point of intersection, 1 and negative 2. Okay, so let's draw these functions. We're not going too far left or too far right. We're not going too far up or too far down. Starting off with our y-intercept 1, 2, 3, 4. There's our negative 4. 1, 2, 3, 4. There's that one. Next up, our x-intercept will be at negative 1 and 2. Okay, we see there's an x-intercept repeating, so we were expecting to get a turning point at 2, and we did get that. Now we see that stationary point, there's 1 at 0 and minus 4 here again, and there's 1 at 2 and 0. This is where it's a little bit different. It's not really different, but you'll see it's just going to cause some havoc for you in the exam. And then point of intersection 1 and minus 2, so there's 1 and there's negative 2. Okay, so according to the form that it should be, it should look something like this. If this is our turning point, it should turn there. And this is our other turning point, so it should turn there. And we see this is nothing to stress about. It's actually fitting our form quite nicely. They just want to see, are you going to be able to see that, apply that form to what we've got, even if these are repeating for both of those, but there's nothing too hectic. And please remember to mark your coordinates. So that's minus 1, negative 1. This is 2. This is negative 4. And then our point of intersection over here. There, I said it now. Our point of inflection is 1 and minus 2, like that. And this is our function, y. Okay, so that was D. Let's have a look at question E. You'll see we're going a little bit quicker now through this work. If you've got any questions with regards to it, you're more than welcome to let me know. It's x3 minus 3x. That's plus 2, minus 2. Okay, first things first, we'll get the first derivative. Like so. And then we'll get the second derivative. Let's get to our y-intercept. Make x equal to 0, 0, 0. We're left with minus 2, so it would be 0 and negative 2. Our x-intercept will make our y equal to 0. And again, we are guessing, right? We're guessing what our values would be, our x values. Let's start with 1, and then minus 1, and then 2, and then minus 2, and then 3, and then minus 3. Again, we've got a table mode on our calculator, which does this quite nicely, but we can just use our guessing as well. So we'll start with 1. 1 to the power of 3 is 1. Minus 3 times 1 is minus 3. 1 minus 3 is negative 2, negative 2, negative 2. That's negative 4. It doesn't give me 0, so x equal to 1 is not a solution. Next up, we'll try x equal to negative 1. Negative 1 to the power of 3 is negative 1. Negative 3 times negative 1, that's going to be plus 3. So negative 1 plus 3, that's plus 2. And plus 2 minus 2 is 0. So we see that x equal to negative 1 is a solution. Let's try some more. We'll try 2. 2 to the power of 3 is 8. Minus 3 times 2, that's 6. So 8 minus 6 is 2, and 2 minus 2 is 0. So again, they were quite nice with our x-intercepts. Now, one of these should be repeating because we expect 3x values. It doesn't mean we expect 3 separate x values. It means we expect 3. So it's going to be turning on one of these two, maybe. But we test -2, we test 3, we test -3. But it's not necessary. Once you've got 2, you are already halfway there. So we know that we're going to have one of these solutions is going to be x plus 1. And then we're going to have a type of trinomial over here. And then over here, x plus 1, x minus 2. And we're going to have a third bracket over here. Now, again, we'll do what we did with the previous one. We want to multiply the first term in all of these brackets, and we want to get x to the power of 3. So that's going to be x. And then we want to multiply the last term in all of these brackets and get the last term. So 1 plus 1 times -2, that's -2. And what must we multiply -2 with to get this -2? Well, -2 multiplied by +1 will be. So we see this would be the one that's repeating. So x equal to -1 should be a stationary point as well. We'll see just now. Let's finish this trinomial. X times x is x to the power of 2 plus x minus 2x, that's minus x, negative x, and then -2. Cool, so we've got our x-intercepts as well. And now let's look at our stationary points. We'll do that by making our first derivative equal to 0. We'll solve this and we'll get that it's x plus -1. So it's when x is equal to +1 or -1. Let's see what happens when we sub x equal to 1 in this equation over here. Now, it's not this one yet, but we'll do it in ascending order. So let's sub x equal to -1 first, and then we should get 0 if we did this one correctly. We'll test that, and we see we do get 0. Let's sub x equal to +1 in there. That's 1 minus 3, that's -2, and that's -4. Okay, so our stationary points are those two. Again, we expected this to turn on -1 because we got 2 of the exact same value for the x-intercept, which would be the case. If you get the exact same x value there, it should be turning at that point. And next up, let's get our point of inflection over here. We'll make our second derivative equal to 0, and we'll get that's when x is equal to 0. So then we can say that when x is equal to 0, we sub that back in there, it's at -2. So it's very similar to what we got at D. Looking at this, our a value is +1, which means it should be a smiley at the end. So it's a frowny at the beginning. Cool. Let's see if our coordinates match what we expected to get. I don't see anything too hectic. It seems like we can draw this to scale to a certain extent. So let us do that. It's always easier when we draw it on the line. So, okay, so for first things first, the y-intercept will be at 0 and -2. X-intercepts are at -1, 2, and then we know it's turning there, so there's another x-intercept, in air quotes. And then stationary points at -1 and 0, so that's that over there. And then at 1 and -4, so here's 1, and 1, 2, 3, 1, 2, 3, 4, somewhere like that. And then our point of inflection is at 0 and -2, which is already marked here. So according to this, it should be smiling upwards at our second stationary point, which is this one over here. So it should look something like this. And then at the first one, -1 and 0, it should be frowning. There, that's that one over there. So this function should look something like this over there. And we remember to mark our points. -1, 2, -2, I believe. And then here, 1 and -4. That should be it for question E. Okay, let's have a look at question F. And you guys should have a very good grasp of this by the end of this. There's G. We're trying to draw this. We'll start the same way we do all of them. We get our first derivative. We'll get our second derivative. And then we'll go y-intercept, make everything 0. All the x's become 0, so all of those will fall away, and we'll just be left with a positive 9. So our y-intercept should be 0 and positive 9. X-intercepts will make g of x equal to 0. Let's divide straight through with -1 because this is an equation. We can divide and multiply with whatever we want as long as we do it on both sides. And then what we want to do is we guessing again, right? So we're guessing and we're starting at x equal to 1 and then x equal to -1 and then x equal to 2 and then x equal to -2 and then x equal to 3 and then x equal to -3, etc., etc., etc. But we'll use our table for our calculator for this to make it a little bit easier for ourselves. And we see when we substitute 1 in this equation, we actually do get 0. So we see that x equal to 1 is one of our intercepts. 1 to the power of 3 is 1, plus with 5 times 1, which is 5, that's 6, plus with 3 times 1, that's 3, so that's 9. 9 minus 9 is 0. We'll try -1, it doesn't work. We'll try 2, it doesn't work. We'll try -2, it doesn't work. Then we try 3, it doesn't work. And then we'll try -3. We see that does work as well. Okay, so we found out that one of our factors was x minus 1, and the other one was x plus 3. That would be one of our factors. We know we need a third one, so when we multiply these first terms, we want to get the first term. So x times x times x is x. And then lastly, when we multiply the last ones, we want to get the last one. So -1 multiplied with +3 will give you -3, and then -3 times with +3 will give you -9. So the trinomial for this step will be x squared plus 6x plus 9. Right, so what we're thinking of is we're getting two values over here. So it's turning on this x value. So we expect when we get our stationary point that we are going to get one of our stationary points, x value, will be x equal to -3. Otherwise, something is not Ioba. So let's have a look at that. Stationary points. Let's make our first derivative equal to 0. And then we'll divide straight through with a negative as well, just to save some time. Let's factorize. That's 3x in the one bracket. It's x in the other bracket. Factors of 3 and 3, that will give me 10, both of the signs will be positive anyway. So 3 times 3 will give me 9x, and then 1 times x will give me 1x. The 9x and the 1x will give me the 10x. So we get that our solutions will be x is equal to -1/3, or x is equal to -3. We take these and we sub them back into the original equation. And when we do that, we find that x equal to -1/3 is the same thing. Well, it gives me a y value of 256/27. Not going to draw too nicely. And then -3, we already know is at 0. Next up, let's do our point of inflection over here. That's our second derivative equal to 0. And if we solve that, we'll get that x is equal to 5/3 minus 5/3. We'll sub that back into our original equation because we're drawing the original equation. We get that's 128/27. Okay, now I'm going to leave the drawing for you. You guys can ask me if you got it correct or not. I'll help you with this last interpretation for the original equation. Our a value is going to be -1. So the shape of this should be frowning in the end. And it should be smiling in the beginning. Okay. The end there, it's going to be frowning because that a value is negative. This shape over here is given because of that value attached to the cube there. And then we'll look at question G, which I believe we've already done. Yeah, we've already done G, and then we'll look at H. There's a cat that is very keen to come inside. Okay, so question H. We'll do the same thing we do every night, Pinky. We'll get the first derivative. That's 6x to the power of 2 plus with 10x minus 4. We'll get the second derivative. And that is 12x plus with 10. Cool. Let's get our x-intercepts and our y-intercepts and all of that fun stuff. Y-intercept will make all of the x's equal to 0. That means all of this will cancel out. And we'll be left with -3. So the y-intercept should be 0 and -3. All of 1 mark, so you don't need to show many calculations there. The x-intercept will make y equal to 0 or h of x equal to 0. Then we are left with this. And when we are doing this, we are guessing again. So I leave 1, 2, and then I get my answers, right? Because over here, we're going to have all of our factors, 1, 2, 3 factors. Over here, we'll have one of the factors and then the trinomial. So let's start by guessing. And when we guess, we sub in x equal to 1. And would you believe it? X equal to 1 is one of the solutions. So we get x is equal to 1 will be one of our factors. So we know that one of our factors is x minus 1. Okay, next we sub in another value. We see -1 doesn't work. We see +2 doesn't work. We see -2 doesn't work. And we sub in -3 and we see that that works. So x equal to -3 is working. So x plus 3 should be a factor. Okay, so we know we need to get a last factor over here. And the way that we get the last factor is when we multiply the first term in all of these brackets, x times x times something has to give me that value over there. So x times x is x to the power of 2. X to the power of 2 multiplied with 2x will give me 2x to the power of 3, so 2x cubed, right? And then when we multiply the last term in all of these brackets, we should get the last term over here. So -1 times with +3 is -3. -3 times with +1 will give me -3. Okay, so that seems to be our factor. Let's give them a trinomial over here to show them the steps that we did in between. X multiplied with 2x is 2x to the power of 2. X multiplied with +1 is +1x. Plus 3 times 2x is +6x. That will give me +7x. And then 3 times 1 is +3. So our last factor is x is equal to -1/2. I get the -1/2 by making this one equal to 0 and just simplifying that. Okay. I'll have more information on how to solve those equations from the previous grades, grade 9 and grade 10. But yeah, x equal to -1/2 should be no problem for you guys. Next up, I did not see any of these x values repeating. So I'm not thinking that any of these should be my stationary points. So let's have a look what my stationary points would be. I take my first derivative, I make it equal to 0, like so. I'll divide straight through with 2, like that, and then we'll factorize. It's going to be 3x and x. We're going to be using our factors of 4 and 3 to get 5. And if we look at this, it should be 4 and, yeah, it should, if I look at this, it should be 6 and 5. Our factors will work better if we do better maths. We're dividing straight through with that one. This should be equal to 2. So this would make life much easier because now we see our factors that we get will be 3 and 2. We want to get 2 over here and 1 over there. We want to get +5. 3x times with +2 will give me +6x. -1 times x will give me -1x. +6x minus 1 will give me the 5x over there. So now we see that x is equal to 1/3 or x is equal to -2. We substitute that back into our original equation and we get the stationary point should be 1/3 and -100 over 27. And then this one should be -2 and 9. Let's do our point of inflection by making our second derivative equal to 0. And if we do this, we get that x is equal to -5/6. If we sub that back into the original equation, we will get -5 and 6 and 143 over 54. We'll help you out a little bit with this sketch by going back to the original equation. Let's just see how it should look. According to this value over there, our sketch should be smiling at the end, and it should be frowning at the beginning because this is a positive value. All right, grade 12s, those were the first couple of questions that I gave you to do for homework with regards to sketching these graphs. We'll be looking at a lesson tomorrow again. Enjoy your evening.